Good morning. So we're going to work on the review. So rays, so first one actually, angles are two rays with the same endpoint. So that just means it's going to look like this. So he has two rays and the same endpoint. And remember, when we name angles, we always put the vertex in the center. So everybody, this is the vertex, and it has to go in the middle. Okay, vertex has to go in the middle. For a circle, so a circle is a set of all points in a plane equal distance from the center point. Okay, so that means if we look at a circle, so I think of it like spokes on a wheel, right? So equal distance from the center. Perpendicular lines, okay, two lines that intersect at right angles. So they're going to intersect right here at right angles. I'm going to draw a bigger diagram. So they intersect at right angles. So all of these are right angles. Parallel lines never touch, okay? So they're never going to intersect. They seem the same distance apart. Okay, line segment. Two endpoints with everything in between. So that is for E. I'm going to write it up here. So two endpoints with everything, so all those points, so everything between them, so all those points between them. So like this would be an example. So EF. So EF is a segment and has those two endpoints. Rigid motion. So rigid motion is a transformation. So transformation with the same size and same shape. So same size and same shape. So all those transformations. So a transformation with the same size and same shape. So those are our three transformations, everybody. So those would be reflection. So reflect, rotate, and translate. Remember, dilation changes the shape, changes the size. Okay, dilation changes the size. So these are the three that do rigid motion. Okay, the following construction, everybody. So if we look at it, it's an inscribed, so it's inside, inscribed circle in a triangle. And we construct that one using our angle bisectors. So we construct this one with angle bisectors. And I know that, everybody, because I'm looking right here. Do you see this? So this is our angle bisectors. So all of these are angle bisectors. Okay. So if it's circumscribed, that means that the triangle is inside the circle. Okay. So that one's the circumscribed. So circumscribed triangle. Okay, so perpendicular bisector, everybody. So that's when we do this. We have a line. Okay, I have my 2 points, A and B. And I would take my compass and I would go here. Okay, and then I would go here. I'd go on the same side. Okay, everybody, and then I would draw my line through it. Okay, and that's my perpendicular bisector. And everybody, with my bisector, what that means is that I've cut it in half. So those sides, okay, these are congruent. So I've cut it in half. And yes, everybody, it'd be accurate if I did it with a compass. So everybody, when you do the perpendicular bisector, we're cutting it in half. Okay, so I do my fish, it's perpendicular, makes a right angle, and I cut it in half. So it's perpendicular. What type of construction do we see here, everybody? So when I do this, so these arcs, okay, I make a equilateral triangle because all those sides are congruent. So equilateral triangle. All sides and all angles, okay, are congruent. So they are the same measure. All of them are the same. So, but if I had it 3 centimeters, 3 centimeters, and 3 centimeters, okay, so they're all congruent and all the angles, okay, are equal to 60 degrees. 180 divided by 3 is 160. Okay, so next one, everybody. So this one, it says describe the following rotations. Okay? So if you want to use patty paper, or you can use the rule. Okay, we'll describe the following rotations. So this one, okay. So you can do, so some of these, everybody, you can do combinations. Okay, so I just want to let you know. So this one's going to be a combination. So we're going to go 90 degrees clockwise. Okay, so a direction of a clock. So that's that way. And so it's going to come up here, and then I'm going to reflect it over the x-axis. So I'm going to reflect it up here. Okay. For this one, everybody, we're going to rotate it 90 degrees counterclockwise. If you want to use patty paper, everybody, remember you can always use the patty paper or you can use the rules. Okay, I'll show you with patty paper. So patty paper, everybody, remember, so do the cross. If this pen is going to work, and it is not wanting to work. Okay, so I do the cross and I'm going to rotate it. Okay, and it's going 90 degrees. Okay, so 90 degrees. (90° counterclockwise, which is that way, or I can do everybody. So I could do this. So I could go 90, 180, 270. Okay, so 270 degrees clockwise. Okay, and so same with this one, everybody. So we're right here, and we go 90 degrees. So it would be right there. Some drop. Okay, so that would be B. And so then these, everybody, would be the double prime. So these are double ones. Okay, so on this one, everybody, so we're going to rotate it 90 degrees clockwise. Okay, so I can go 90 degrees clockwise. Okay, so that's that way. Or I can go 270 degrees counterclockwise. So everybody, counterclockwise would be this way. So we'd go this way, 1. So this is 90, 180. So 180 and 270. It's also 90 degrees clockwise. Okay, so this one, I look at this. We're going to rotate 180 degrees, and we can go clockwise or counterclockwise. So remember with 180, we can do either way. And everybody also remember, I know that because I'm looking for those little prime marks. That's how I know that this is the one that I rotate. Okay, remember that's how I know. Okay, so vertices. So we're going to have to graph it. Okay, so we're going to have to graph those points. So I'm going to have to go 1, 2, 3, 1, 2, 3, 4. Okay, and then E, 1, 2, 1, 2, 3, 4. And F is that. Okay, and they want us to reflect over the line y is equal to negative x. Okay, so with that one, everybody, we go ahead and switch the coordinates, and they also change signs. So if you like to do it that way, you can also just take and, okay, so I'm going to reflect it over. So I have the point D, -3, -4. So it's going to, for D prime, it's going to become 4, 3. So we change signs. So for E, it's -2, -4. So we're going to switch them. So it's going to become 4, 2. So they became positive. For F, -3, 0. So it's going to become 0 and 3. Okay, notice 0 is neither negative or positive. Okay, and then we can go ahead and graph it. Okay, so we have this one. So 0, 2, 3. So F is going to be right here. And then E, 1, 2, 3, 4, 1, 2. And then, so 4, 1, 2, 3. So right here. So 4, 3. Okay, so everybody, you can also do this with patty paper if you want to do that. Okay, so this one, what's the rule for the translation, everybody? So translation means that we translated it. So we're going to have, I look at it. Okay, so remember for this, everybody, so also help you in algebra 2. So if it's negative, if it's left, positive if it's right, positive if it's up, negative or minus if it's down. Okay, so I look at it, everybody, and I go, okay, so I'm going from B, and this is B prime. So I pick one point, I go, okay, so I went, careful with the scale, everybody, this is actually going by 2. So I went left, 2, and then down 2, 4. Okay, so down 4. Everybody's so careful with the scale here. Okay, so look at the scale. So it would be x minus 2 and y minus 4. That would be my rule, everybody. So I went up and I went down. Okay, rotational symmetry. So this one, so let's look here. So we have our equilateral triangle, everybody. So remember, we can look at the center. If you want to trace these with patty paper, that's definitely an option for you, everybody. So I look at how many lines of symmetry I have. I have 3. Okay, and so that means that I can rotate it. So 220, 240, 360. Okay, so for this, everybody remember how we do it. It's going to be the 360 everybody, divided by the number of lines of symmetry. Okay, and that's how we figure it out for this. Okay, this one, so we're going to take and rotate it. So I look at this one and I know I have 1, I have 2, 3, and 4. So I have 4. Okay, so 360 divided by 4 is 90. And then I'm just going to keep adding 90. 90 plus 90 is 180. 180 plus 90 is 270 degrees. 270 degrees plus 90 degrees, everybody, is 360. Okay, so these are all my degrees of for my rotational symmetry, everybody. Okay, this one, everybody, so our pentagon. So our pentagon, everybody, has 5. 1, 2, 3, 4, 5. 360 degrees divided by 5 is 72. 72 plus 72 is 44. 144. 144 plus 72, 216. 216 plus 72, everybody, is 288 degrees. 288 degrees plus 72, everybody, is 360. Okay, this one, everybody. So this one is going to be, we end up with 6. 1, 2, 3, 4. So this one, so 1, 2, 3, 4, 5, 6. There we go. I swear I get that. So 6. Okay. So 360 divided by 6 is 60. And then I just keep adding 60 every time, everybody. So I'm just keep adding 60. So I'm going up by 60. So those are all our lines of symmetry on that one. Okay, remember symmetry, so we can fold it onto itself. So I can take and fold the paper. For all the diagrams, everybody. Okay, number 9, everybody, so we got this. Okay, so number 9 is going to be, okay, it says the composition of transformation was performed on ABC. So this is the preimage. So I know that because there's no prime marks. This is the first. Okay, and then this is going to be the second because it has the double prime. Okay, so it says describe the transformation. So I look and how can I get from here to here? Okay, so everybody, so this is where I start. I notice that A is in a different position than A prime. So that means that I reflect over the y-axis. Okay, so that's my first one. Okay, and then I'm to go from A prime to A double prime, everybody. So I go down, I look at the scale, it is by 1. So I go, okay, so I went down 1, 2, 3, 4. Okay, so down 4. And then I went left 3. So my second one is that I translate it. So minus, remember left is going to be negative, so x minus 3 and y minus 4. Okay, this one, it says, use the diagram below, everybody, to find the angle pairs. we got to find our angles. So this one, so vertical angles. So 1 and 4. Corresponding angles, same side, skip 1. So 4 and 8. Consecutive interior angles. So remember, those are the ones that equal 180. So I have 5 and 2. So those 2. And then consecutive exterior angles. So those are going to be ones outside, and they are supplementary, so they do equal 180. So 1 and 6. Okay. We also have alternate exterior angles. So that would be opposite sides outside. So 1 and 8. Okay, and alternate interior angles. So that would be 2 and 7. Linear pairs. So those are ones that also are equal to 180, and they are next to each other. So like 1 and 3, 1 and 2. Okay, so they're next to each other. If measure of angle 1 is 100 degrees, okay, what angles are also 100? So everybody remember, we can do our zigzag. So if I do my zigzag, it's angle 4, so vertical angle. Alternate interior is angle 5. And then 5 and 8 are vertical angles, so they are also 100 degrees. Okay, so next one, we're going to solve for x, everybody on these. So if this one's 84, they're asking us what this angle is. It's also going to be 84 degrees because they are alternate interior angles. They are inside the house, alternate interior. So these are corresponding. Same side, skip 1, so I can translate down. This one, these two are a linear pair. So I add these together and set them equal to 180. I'm going to combine the like terms. So 5x plus 9x is 14x. 15 plus 11 is 26. I'm going to subtract 26 from each side. I get 154. I divide each side by 14, and I get x is equal to 11. Okay, this one, these are consecutive interior angles. So that means that I'm also going to set them equal to 180. It's the same numbers as before, so I'm going to go 11. Okay, these are vertical angles. So I'm going to set them equal to each other and solve for x. Subtract 5x from each side so I can get x. X is all on one side. So we get x. Bring down that 10, it's 10. Okay, the measure of the angle. So I'm going to substitute in 6, 6x. So I substitute in the 10. 6 times 10 is 60 degrees. Okay, for this one, they are corresponding. So I'm going to set them equal to each other. Okay, so 7x plus 5 is equal to 6x plus 13. Subtract 6x from each side. Remember, we have to get the x's all on one side. Subtract 5 from each side. Remember, we want to get the x by itself. Let's go away. 13 minus 5 is going to be 8. What's the measure of the angle? So I'm going to use one of these. So 7x plus 5. I'm going to substitute in that 8. 7 times 8 is 56, plus 5 is 61. Okay, this one, given that the alternate angles are congruent. Okay, so that's our given. Remember, we always start with our gibby. So I'm going to start with a pair of alternate interior angles. So I'm going to choose C and F. Okay, and that is our given. Okay, and then I'm going to do C and B. Okay, for our vertical angles. So angle C is congruent to angle B because those are our vertical angles. And then we know that B and F, so everybody now I'm looking at these two, are corresponding. So angle B is congruent to angle F because those are corresponding. Okay, so now now we know we can do our proof. Okay, so now we can do our proof, everybody. So we know that line R is parallel to line S by our CAC. Everybody, that's our corresponding angle converse. And I know I'm going to use that one because I have to prove that the lines are parallel. Normally we're given that the lines are parallel, but I have to prove it. So our given, remember our given is right here, okay? And our prove is always going